Hello everyone and welcome to Azam Shah Weekly. And in this video, I'm going to show you that how you can migrate your existing SwiftUI MVVM application to the MV pattern or the pattern that Apple is using. All right, so let's go ahead and get started. Let's go ahead and first check out all the code that we have already written. This is using the MVVM design pattern. The application does work. So if I go ahead and let's say run the application, I'm going to run it in a simulator. And this application uses a JSON API to fetch some orders. It's a custom API, don't worry about that. It lists the name of the orders like John Doe, Mary Doe, and Ed. You can go and check the details of the order. It just has some coffee stuff going on, coffee orders. And I can go ahead and add a new order over here. So let's say that if I'm adding an order, I'll say Steven, let's say hot coffee over here, and whatever the price is. So you're basically a barista, all right, and you're putting these orders. Large, place order, and there we go, Steven. Okay, so all of these things are actually being added. Let's go ahead and take a look at the code. Now, keep in mind there are so many different variations of MVVM with SwiftUI. So I'm just using the most common one, hopefully. I checked out a lot of implementations online, and I think people are using it in this particular way. All right, but again, there are like infinite amount of variations I have seen. I have a HTTP client. This is more of a generic JSON client, so that instead of writing get all orders and adding an order as a separate function or a separate method, I only have HTTP client, and that calls the load function, and we pass in the resource, and it does what we want it to do based on the URL and some parameters. APIs simply have some hard-coded APIs, nothing crazy. The project, the server, is hosted on Glitch. You don't really care that much about the server. Let's just say it's a third-party server, all right? And then we have the model, which is the coffee order. And the coffee order has an ID, name, coffee name, total, size. The size, I'm just using coffee size as an enum, so I can also display as a segmented control. I have a couple of different screens. I have a coffee order list screen. This screen is responsible for displaying all the orders, as you can see on the right-hand side. And I can navigate to a different screen also. I can also go to the add order screen where I can add an order. Okay. For the coffee order list screen and for the add coffee order screen, I do have some view models associated with that screen. So for the coffee order list screen, I have a view model called coffee order list view model. Now again, as I mentioned earlier on, there are so many different variations of the MVVM pattern with SwiftUI. Some people like to create one particular view model per screen, and I've seen some people that they also like to create coffee order view model. Like if they want to represent every single order on the view, then they will end up creating another view model. I've seen that, another view model, let's say coffee order view model. And what it will do is it's going to simply take in the coffee order, which is a model DTO basically. It doesn't really have any logic anyways. And we're going to take that, and then we're going to just return these different things, values from the actual model itself. All right. Why would anybody do that? Why would anybody create coffee order view model? Why not simply use coffee order? Well, in some implementation, I've seen that they were doing some sort of a formatting over there. So that can be one of the reasons. But in most implementation, I haven't seen that. So we are not really going to be creating or subdividing our coffee order list view model into sub models. All right. And then basically what they do is they put this thing over there instead of the DTO object. Okay. That's just a different way of doing things. But I think that's going to create way too many models for us. Okay. So here we go. So this is the most common approach, at least that I have seen. Coffee order list view model takes in the HTTP client. Again, if it will be a good idea if you're using mocking to create a protocol and not create concrete classes, but I just want to create this simple example, so I'm not creating protocols and all that stuff. If you look at our hot coffee app, this is where we are creating the coffee order list screen. Okay, the coffee order list screen has a dependency of the view model, so we pass in the view model and then we pass in the HTTP client, because the coffee order list view model depends on the HTTP client, so that's why we're passing it over there. The same thing we kind of do for the add coffee screen. So coffee order list screen basically fires up the add coffee order screen, which has a dependency on a particular add coffee order view model, which has a dependency on the HTTP client. Again, you might be looking at this and say, hey, I don't do that. I never have done this before. I use a completely different approach. That's perfectly fine. I just gathered around many different approaches from online, and this is the most common one that I have seen. Now, if you disagree with that, that is perfectly fine too. As I mentioned earlier on, there are a lot of different implementations for MVVM and SwiftUI that you can use. All right. In the add coffee order view model, and this is where it gets a little interesting, the add coffee view model contains the HTTP client because that's where we're going to make the request. It has all these published properties so that we can inject these or kind of like bind these. And the place order function, now, since we're inside the add coffee order view model, we need to tell our add coffee order screen that we have added something. So in the place order, I simply pass in a closure that will be called eventually when the order has been placed successfully. Okay. Now, some of you might use combine and publishers and all that stuff. That is perfectly fine too. Whatever makes you happy, all right? And finally, in the add coffee order screen, once we place the order using our add coffee order view model, then we simply append it to the coffee orders, which are already passed to you. So we're passing in the coffee orders. And the reason that we pass in the coffee orders over here is that so our coffee order list screen can refresh so that it will know that, hey, something got added to the coffee order. So that's why we're passing it over there. Okay, great. So how can we, or why should we convert this into a different pattern that Apple is using? The pattern doesn't really have any name. We just call it MV. But MV doesn't really mean that you're putting all your code in your view. I think that's a very big misconception people have. And when I'm going to implement this pattern, you might say at that point that, hey, hold on, this is, you just renamed the view model to something else. If you have that thought, stop and watch the video 10 times. All right. So let me show you what we're going to do. So what I want to do is the source of truth in this application is the same. It's a server. Server is the source of truth. All right, so remember that server is the source of truth. So let's see that what will be the different thing if we try to migrate this MVVM and SwiftUI. And obviously this is a very simple application, consists of only 2-3 screens. But what will be the migration look like? How will it end up if we try to migrate it into like an MV pattern, for a better term? Okay. So the first thing I'm going to do is inside the models, or you can create some sort of a data stores or whatever you want to call it. That's fine. Okay, so let's see that how we can get started if we want to migrate our existing MVVM pattern application to MV. And the reason that we're doing that is that you will end up, if you're doing these view models for every single screen, that you will end up with a lot of different view models. And that is, it will be like in thousands and thousands of extra lines of code. So let's see how we can reduce that. So inside the model, I'm going to go ahead and add a new file. Now, this is where the actual confusion starts for most people. All right. What should we name that thing that we're adding? Some people like to call it store. Some call it data store. I call it aggregate model. Aggregate model simply means that this is kind of like your entry point from the view, and that model job is to give you access to the other models, kind of like an entry point into coffee order, entry point into user, entry point into inventory, whatever you want to call it. Okay, so I'm just going to call it model just to be safe. Now, I know some of you are like, okay, why did you call it model? Can you call it something else? Okay, so in actual application when I'm building, I usually try to call it I just create one model, aggregate model, and I just call it kind of like this, hot coffee model. All right. So right now I'm just going to call it model, but don't get stuck with the name. I think that's the main confusion that people have, is that they get stuck with the name. If you want to call it data store, perfectly fine. You can call it data store. You can call it store. You can call it Scooby-Doo, whatever you want to call it. I'm just going to call it model. This is aggregate model. Okay. Now, it's going to be a little bit different than the coffee order. The coffee order is a model, a DTO, which represents the coffee. But the model over here that I've added, which I would like to call aggregate model, the job of the aggregate model is not really to represent an entity, not represent anything in real life. The job of the model or the aggregate model is to simply give the data to the view. That's it. That's it. All right, let's go ahead and start it. Class model, observable object. Wow, that looks exactly like a view model. Yeah, it does, with one difference. We'll see in a moment. Okay, I can actually even go to my coffee order and just copy some stuff from there. There we go. And I can actually copy all of this stuff, right? I mean, all of these things, I can just start copying it into my aggregate model over here. All right, so the naming is not that important. You can name them anything you want. Okay, well, it looks exactly like our coffee order list view model. We literally pasted the code into our model, which we call aggregate model. Literally, right? Let's go ahead and build it. Okay, it builds successfully too. Okay, now I'm going to go into my add coffee order, blah, 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 add coffee order view model. And I think I'm going to go ahead and add this place order. That's the one that I need. There we go. Okay, place order, I guess that's fine, but I'm going to remove that part. I'm just going to say order. This will be coffee order. So you will be passing in, somebody will be passing in the coffee order. And then we can do all of that stuff. We can save it. Let's see what's going on over here. Coffee order. Should I call it coffee order over here? Coffee order. And when we save the order, we already have the order right on the top of line number 15. I'm just going to append it right there. Save coffee order. There we go. Let's go and build it. Okay. So what I did is I went to every single view model and I got the code for it and I just pasted it into my aggregate model. Now, some of you will be like, okay, so you simply change the name of the view model to the model. If you like to think like that, that's fine. But this model is not only for ordering the coffee, or let me rephrase that. The responsibility of this aggregate model is not binded to a particular view. It's for everything. All right, everything. Everything related to the orders, everything related to inventory, catalog, categories of orders, everything. So this particular aggregate model is going to be responsible for managing the entire state of your application. Okay? And I think that's the hard part for people to understand, that when they see this, they're like, oh, you just rename your view model to a model and that's it, that's all. Well, that's just part of it. What we did is we combine all the functionality of the view model and we put it in the aggregate model. That's what we did. All right. So let's see how we can use this now. Again, the name is not important. You can call it data store, you can call it store, you can call it whatever you want. What about if you're working on a much larger application? Can one particular aggregate model data store manages the entire state of the whole big application? Well, in those cases, you will have to divide it. But you don't have to divide it based on the screen. See that? when we had the coffee order list screen, we created coffee order list view model. That's one view model right there for one screen. Following? When we had add coffee order screen, we created another one. So that's two. Now, in a normal application, you may have like 10 screens or 15 screens or 20 screens. Screens, not the views itself. I mean, yeah, screen is a view, but I'm talking about actual screen. A screen may have some different views over there. I mean, one of them can be like a list view and some custom views that you create. But 20 screens mean 20 view models. All right? Keep that in mind. Okay. So how do we use it? Well, the first thing we need to do is we created this aggregate model, data store, whatever. We want to inject it somewhere. And one of the things that you can do is you can simply inject it into the environment. So I'm just going to work on the coffee order list screen. I'm going to go ahead and say something like this, environment object, and this is just for the Xcode previews. And I'm just going to inject the model. The model does have a dependency on HTTP client, so I'm just going to go ahead and pass in the HTTP client. If you are mocking, then make sure that you are using and creating HTTP client protocol. Okay. Now, the coffee order list screen was dependent on the view model, so we can remove that part. We don't need that. There we go. Okay. And how does it access all the stuff? Well, we will use the environment object, private var. Now you can call it anything you want. I'm just going to call it model. And what did we call it? Model. Okay. So it should be model.orders. You can see the similarity. There is similarity. I'm not saying that there is no similarity or anything. There is, of course, similarity. And then I will say model.load orders. Okay. I think that should be an add coffee screen. We will probably talk about it a little bit later. Okay, what did we mess up? Okay, the model doesn't have to be private because it is the environment object. And HTTP client is, okay, so HTTP client, I guess, is also private. Yeah, it doesn't have to be private in the model, in the aggregate model. I think that should do it. Not sure why it's complaining over here. I thought we already made that. Okay, let me go back into my model. This is fine, and this is also fine. We have published property and all that stuff. I think it might be coming from somewhere else. Let's go back to our, over here. You can see that I'm still using the old stuff. So I'm just going to say this is the actual app file. Okay, so this will be coffee order list screen. Okay, with nothing. And this will be environment object. We're going to inject. That will be a model with HTTP client, which is simply HTTP client. Create an instance, obviously, of HTTP client. Oh, sorry, shared, right? Yeah, I totally forgot about it. Shared. So let's go back. I think that's the mistake that I'm doing over here also. Shared. And if the HTTP client has a protocol, then you can go ahead and inject some mock stuff, and that's perfectly fine too. Okay, so this looks good. Little bit of code is cleaner. I mean, I'm not saying, oh, it has completely cleaned or anything, but definitely little bit of code is a little bit cleaner because we don't have that dependency into dependency and all that stuff going on. Well, actually, we kind of do have a dependency to dependency, which is right over here, but you'll see in a moment, all right? That's how it's a little bit cleaner. Okay, so let's go ahead and see if it actually runs. So we should be able to display it. Okay, so everything works. It displays it. When you look at it, you're like, I mean, what did it even do? All right, let's go to the add coffee order detail screen. Now for the add coffee, we're going to do the same thing. We're going to remove the view model itself. We're going to remove the coffee orders also. We don't need that stuff. Okay, deleting is always fun, right? What about the view model name? Where is this going to go? Now you have multiple options over here, and these options you already had when you were doing MVVM also. So depends how you're doing. You can do something like this. private, what is it? Private, well, you can create like these local states. That is perfectly fine. All right. You can also kind of like combine them together into a struct of your own. And then we have, what are we, total? I think total is double. We'll just call it 0 or something. And I believe we have size, which is coffee size or something. And we'll reset it to medium. So I can remove all of this stuff. I mean, I added some code. All right. And all of this stuff we don't really need. Okay. Okay, place order doesn't really work right now. So we did deleted some line, we did added some line. Now all of these things that I've written over here, you can extract it out into just a struct, and then you can use that. All right, that's perfectly fine. Okay, let's fix this in the preview. So we are not really passing anything anymore like this. We are, but we are still passing environment object with the same thing, with the model, and passing in HTTP client. So HTTP client.shared. Okay, let's go ahead and build it. So how do we place an order at this point? Well, we already have the model. Well, we don't. Let's go ahead and add that. Not sure what happened to the model. I thought I added it. Model, which is simply the aggregate model. The aggregate model contains everything related to our application. It's maintaining the entire state. So if I want to place an order, I'll just call place order, which is a function on the aggregate model, and I will simply pass in the actual order. So I'll say coffee order, or just order in that case, equals to coffee order, and then simply pass in all of this information, like name will be name, coffee name will be coffee name, total will be, I guess, total, and size will be the size. And then we can pass the order over here. This will be a try await function. You can, all of this thing, you should probably create a smaller function called place order that is going to initiate the place order. All right, so you can definitely do that. And I don't think we need that. I think I wrote it in a little bit of a weird way over here. I have multiple do stuff going on over here. What I'm going to do is I'm going to say create an order, which will be a coffee order, and name, coffee name, total, and size. Once we create that, we can use the model dot place order, and we can, so this is fine. And then we can do try await. Again, you can move this stuff into a separate function. I think that is a much better approach. Whether you're using MVVM, whether you're using any different way, you can do that. Okay. And that's hopefully it. Okay, let me go ahead and try to run the application. I will go back to my coffee order list screen. Oh, we still need to make sure that our sheet is presented. So add coffee order screen. I don't think it takes in any parameters now. It's nice and easy now. We don't have to pass an array of all coffee orders anymore. Let's go ahead and add an order. Okay, I'm going to say Elaine, coffee order this, 5 large. Okay, I think it might have been added. Here we go, Elaine is added, but I think it just didn't dismiss. So what we can do is over here, we can dismiss it. Not a big deal. There we go. Okay. Now we can go over into view models part, and we can simply delete the whole folder. Let's go ahead and build it. If you're using it, it's going to give some errors. But we are no longer using our, view models. Pretty cool, right? So what did it buy us in the end, right? I mean, what did we even achieve with all that stuff? Well, one of the things that we achieved with all of that stuff is that now all of our screens are hooked up to one particular thing. You can call that thing the model, you can call that thing the data store, you can call that thing to anything you want. If you have 20 different screens, that model can provide the data to 20 different screens. You don't have to create a view model for every single screen. Because when we were creating view model, then we were also running into some issues with updating, right? I mean, we were passing in the orders array, we were adding that closure, or maybe you were using combine, right? You can use any of those things. But now it's kind of like a single source of truth because the source is the server, or the source of truth is the server in this case. When people usually see this kind of approach, their common behavior is, oh, you just named the view model into a model. And you can kind of think like that if you want to. Just make sure that you understand that all the view models are now joined together, if that's a good analogy, and they are now considered a model. The model job, the aggregate model, I should probably write this as aggregate model. Aggregate model, the job of the aggregate model is to simply provide the data to the view, and that's it. Okay. Now, a question then comes during these things is, okay, hold on. What about if I want to sort the data? What are you going to do that? I mean, I used to do that in the view model, like a coffee list screen view model, all that stuff, but where should I do that now? So if you want to sort your orders, this is how I would do it. I would simply create a property over here, sort orders, or sorted orders, right? Sorted orders. And what are we returning? Coffee orders, probably. Coffee order. And write the code for sorting the order right here into your view itself. So what should it be? Well, I think it's model.orders.sorted. And again, it depends what you're trying to do. I'm just going to say left-hand side, and oops, not that. Left-hand side, and this is right-hand side. And then we can say left-hand side dot, I don't know, name maybe, less than right-hand side dot name. And let's go ahead and build it. And hopefully it will sort in some order. Instead of using the model.orders, I can simply go ahead and remove that and use sorted orders. And I think, yeah, there we go. It actually sorted. Nice and simple and easy, right? If the sorting or the searching or more like a data transformation or presentation logic is quite complicated, then you can think about separating it into a struct. And then you can test out the struct also. Okay, so if you're wondering about how do you test this? Well, how do you test this is just by looking at the Xcode preview, and I'm happy with it. All right. Now, if you want to write a test for it, then you can extract this out into a struct and then use that. For this simple scenario, I'm not going to do that. It's not just feasible. All right. Now, keep in mind that when we are using this kind of approach, we have to keep in mind that we are composing our views correctly. So the coffee order list screen is not a reusable control. It's a container view. Container view is very, very common in React applications. The container view is responsible for downloading the data, maybe performing some operations on the data, transformation operation like sorting, all that stuff, filtering maybe. And then we have presentation views, which are tasked to display the data. In this case, the presentation view kind of like for us is list, but if this becomes a little bit more complicated, then I would move it into a coffee order list view, something like that, or coffee orders view, something like that. All right. You can even divide this cell into coffee order view cell, which this is not like for a MV pattern or a particular pattern. You should be doing that no matter what kind of a pattern that you're using. All right. So now, right now, if you see this, you might say you didn't really earn any benefits. All the code is inside the model, right? But think about one thing only. What will happen if you have 10 different screens that need the data? and you will end up with creating 10 different view models, right? So instead of doing that, you can create an aggregate model, data store, Scooby-Doo model, whatever you want to call it, and that particular model will be responsible for providing the data to the view, and that's it. All right. It's definitely very similar to MVVM. You can even think of it like saying, oh, I just created a global view model that is going to provide the data to all the views. That is great. That is fine. If you want to think it that way, that is perfectly fine. Some people do like to think it as a global view model. If you want to, that's perfectly fine. If you want to do sorting in some other controls, then probably it's a good idea to perform the sorting operation, move it into the aggregate model. Like you can create a function over here, sort whatever, like maybe it's a function like a generic thing, and you can do all of that stuff. All right. So this approach is ideal if you are building a client-server application. If you are building a core data or Swift data application, then I would recommend that you check out code from Apple. They have a number of apps like I think Backyard Birds, where you can learn a lot about Swift data and how to architect those kind of applications. All right. And I will also link the article I will also link the article in the YouTube description, so you can use that also. Okay. Now, other case, I do want to cover one more case. The other case is, let's say, and you can forget about this one, I guess, if you want to, that's fine. Let's say that somebody was saying that, hey, in the coffee order list screen, we just want to display all the orders and nobody can modify the orders. So I don't want to keep track of anything. I just want to just display the orders. All right. So I'm just going to give you another implementation also. Coffee order list screen 2. Now, I usually don't use this kind of implementation, and the reason is that most of the time in my applications, when I am holding on to a number of coffee orders, I do have other screens that are going to manipulate those orders, like adding an order, deleting the order, and all that stuff. But that's not always the case. I mean, if you are consuming an API where you can simply consume it, but you cannot really, you cannot really update it. And I mean, there are a lot of APIs online that you cannot update it, right? You cannot do add, you cannot do update, you cannot do delete, only get operations. So in those cases, you can use this approach. So over here, I'm going to say HTTP client. So you can now see that I'm directly accessing the HTTP client over here. HTTP client. HTTP client. And again, it really depends on the situation. I would not say that you should just start doing this all the time. This is a very special solution for a special problem. And we'll say orders, which will be coffee orders. This is a solution actually being used in React for like 13 years maybe, or whenever the React was released. And I'm going to say, this is even more simpler, I guess. Orders, and I can go into an order and I can display the order, I guess, the name of the order. And for the task, I can use HTTP client dot load. Oh, now I have to create the resources, right? So resource equals to resource with the URL, which is apis dot orders dot URL. And what is it going to return? Coffee order, I think. Coffee order dot self and resource try wait, and we will get orders. There we go. Again, you should probably move this into a separate function. That will be much better. All right. Not sure why it's complaining over here. Oh, non-throwing. I guess so we have to take into account that this is a throwable function. Private error.localize description. When I see this kind of a code, I really like to move it into a separate function. So I'm just going to do that just to show you that this is possible. Load orders, load coffee orders, if that suits your appetite. And there we go. And I'm going to just move kind of like all this code over here and then call the load orders from here. Try await, right? Try await. Oops. Oh, no, something I did wrong. This is not a throwable function. This is just await, because when we throw it, we catch it. And that should probably display the orders. There we go. Much simpler. All right. Now, this is a very special case. This is a case where you are trying to consume an API onto a particular view or a particular screen, and that screen is not really going to be modifying it. Because if you try to modify it, then it becomes, you can still do that with the bindings and everything, but I don't really like to use that. Then I will just put it inside the environment object, and that's pretty much it. But there are a lot of cases where you're consuming an API where you're not allowed to perform the post action, right? So you're just displaying it. I mean, there's hundreds of APIs out there, like the OMDB API, the restroom API. You can simply consume it. So if you want to consume it and not hold on to the data so other views can modify it, you can use this approach. Now, keep in mind that they can modify it if they want to, but you will have to pass it as a binding, all right? But it becomes a little bit weird when you're passing it as binding. So, wow, this is a long session. But hopefully you have learned a little bit about my approach of how I use SwiftUI. That's not to say that your approach is wrong or something. I think you may be seeing a lot more similarities rather than differences. And hopefully this kind of approach will help you eliminate unnecessary code that you may be typing. So if I want to go to the add coffee ordered screen and I want to validate something, I will simply go ahead and add the validation in right here. Is form valid and Boolean return true. And all the validation stuff, I can just put it right there in my screen, which is a container view, not a reusable presentation view. Keep that in mind. So that's it. Wow, a long video. I really hope that you have enjoyed it. If you have any questions, write it in the comments. Thank you so much. If you like this video and want to support my channel, then check out my course, MV Design Pattern in iOS, Build SwiftUI Apps, Apple's Way. So this is a complete course which is going to cover how the MV pattern works, the validation, and we're going to look into a coffee ordering application. We will do the end-to-end testing, updating grocery item. We will also set up the core data. So I'll show you all of those different things. So check it out. The link will be right there in the description.